Howdy. Hopefully, you are aware that we have a very big coronal hole facing Earth, and I've been talking about this probably in my last video. And hopefully, you also know that where we have coronal holes, there is a high-speed stream of solar wind impacting Earth. In other words, it's very windy and it's dark plasma. And this is geospace magnetosphere cut planes density. So this is Earth here. This little small thing here in the middle is Earth. Now let's just watch this. In order for me to show you something, this is Earth's magnetosphere. The sun is here to the left. This is how it looks from above. Here we are looking from the side. And as you can see here on the right side of the screen, where it stretches into space. And obviously there is no coronal hole stream impacting Earth right now, because when it does so, this gets really compressed. It gets really close to the Earth. Here the shock wave, what is it? Oh, I don't remember the word now. Anyway, this boundary gets much closer to here because there is a push coming from the sun. So, I have been talking about somewhat a similar thing in one of my recent videos. Here we go to solar system scope, where we have Earth here. Here Earth, and then we have Venus just in front of Earth, and even Mercury. And this is now. And as we go on in time, we can see that Venus gets ahead of Earth. Yeah, that's really a bit stupid. That cannot. So there seems to be this kind of a. Let's go still on a little bit. There is this shape what I have been talking about, which is about the interplanetary magnetic field lines. And this is from an elderly video where I have been talking explicitly about these things. And I will put a link below, and in this video I even drew a very sketchy graph. Yeah, but here we have Jupiter, Saturn, Mars, Venus. And the interplanetary magnetic field lines, they are spiraling towards the sun because the sun is spinning. So they are not straight connected. There is no straight line, basically nowhere. Everything is curved, at least slightly. And this was a video about some possibility of the outer gas giants making a connection to the sun that could have possibly triggered the Carrington event eruption due to their alignment, and they made the connection. Basically here I'm talking about Saturn and Jupiter vector. So we have now this very large coronal hole which is facing Earth, and where did it go? Venus actual time is still aligned basically with Earth, and Mercury is also still basically, it's almost a completely straight line at the moment. But as I have just shown you, due to Earth's Sun's spinning direction, there will be this delay. And I think I've been talking about this in another video, because I think it's very important to recognize this. Also, it's very important to recognize that, let me show you this first. Sulfur on Venus, atmospheric surface and interior processes. Sulfur dioxide mixing ratio 70 kilometers in the atmosphere of Venus. So there is a lot of sulfur on Venus. That's why it's yellow, I guess. Is there anything else? I will put links below, you can check this out. But there is sulfur on Venus. This might be more important than many people think. Because in one of my videos I have been talking about the sulfur effect on ripple formation and penetration. And this is about welding. And I think somewhere should be oscillatory Marigoni flow, a fundamental study by conduction mode laser spot welding. Through Marigoni flow, a surface active agent can affect not only the weld pull depth, but also the pull surface deformation, pull surface oscillation, and ripple formation. Maybe the weld pull depth is the most important thing in this case. And there is a very interesting picture here. Here are just some drawings. I will put links below to this. You can check it out by yourself, which I really recommend. Sulfur effect on ripple formation and penetration. 42 parts per million sulfur. We have a shallow crater. And here we have a laser beam. This is where how they were checking this whole thing out. And you have to recognize that the universe is electric. This is electric. We have light, energy, and all the same thing like the sun does. So here on the left, yeah, that's annoying. Here on the left, 42 parts per million sulfur, a shallow crater. 140 parts per million, we get a deeper crater. And if you are able to imagine that this CO2 laser would be, let's say, the coronal hole stream that pushes the atmosphere of Venus. If this would be Venus, if there is a much higher stream coming from the sun, this will get pushed much more further behind Venus. And as I showed in my last video, they think that the magnetotail of Venus could reach Earth. In other words, there's a lot of sulfur on Venus, and if it reaches Earth, the impacts could be much heavier than anticipated. Because if we go back here, for example, geospace magnetosphere cut planes density, parts per cubic centimeter. All right? Now let me show you the other two as well. Velocity. That's the velocity. Geospace magnetosphere movies. And we are watching at some professional, like NOAA website, you know. So we have here the velocity. Then we have the density. And then we have the pressure. Now let's take a look at this. Maybe here we can, like here you can see magnetotail of Earth. It's wobbling. Obviously, we are under pressure already. And here you can see how stuff is basically leaving behind Earth. Blobs of material leaving behind Earth. Yeah, I'm totally aware this is just a model. This is a computer animation of something. But in my last video, I have been talking about this, that scientists think that if this would be Venus, the tail of Venus could reach Earth. And if we have this huge coronal hole, this one here, which is one of the biggest in many years, obviously, there is a lot of high-speed dark plasma coming out there. So this tail of Venus gets very long. But this only can happen I think, at least to some degree, when Venus is a little bit ahead of Earth. Because here we have the interplanetary magnetic field lines. Of course, if we have a CME, they go more or less straight. And here we have the page, ISPA, GSFC, NASA, government, blah, blah, blah. All right. Here we have Earth. Here are some of the squares or satellites, and I think this yellow dot here, let me go to the beginning somewhere we can see the whole thing. Earth, Mars, Mercury, Venus. Earth, Venus, Mercury, Mars. All right? Probably. Yeah, it might be something like that. Okay, we have the interplanetary magnetic field lines, and we have the inner planets. Earth, Mars, Mercury, Venus. The n little spiral magnetic sector boundaries and CME events. So I thought that I have to go to check this out and look what's going on at this moment, because I'm interested into what is going on in the next few days on a bigger scale on Earth and stuff like this. So I went to ISWA, and here we have the end little forecast, nowcast, and I have been trying to find one of them, but here we have only Earth. We have the field lines, but there is no satellite. And I really wonder, what's the problem? Let me just forecast. There isn't any, there's just two. N little density and N little forecast, nowcast. N little, N little. And we are watching N little forecast. So what I find rather odd is that where did the planets go? Why don't we have satellites? What's the thing? Why? We only have Earth, and we can see here there is a rather dense line. They are very close together, those interplanetary magnetic field lines, which is no surprise because we are, yeah, they are rather close together. And of course, this is not to scale. But this is an island density. Here we don't even have the interplanetary magnetic field lines, but we have the density. But why there is no planets here? Let's just take a look at this. Do we have here VSA and little? It's the same. Do we have planets here? No, there's just, maybe that's a satellite, I don't know. They don't tell here what that is. I guess it's a satellite, I might be wrong. So why are there no other planets or whatsoever things anymore on these models? Especially at this very important, here we have something. Check it out, Earth, Jupiter, Mars, Mercury, Venus. Yeah, now I found it. That's very interesting. And also that's interesting, that's reaching the other model. What's going on? So there is a huge scrambling of things here going on. But this is in a way unstoppable. And I don't know if I can zoom in into that. No, it doesn't. Yeah, actually, yeah, it does. So the green one is Venus and the yellow one is Earth. Earth, Venus, Mercury. And all those interplanetary magnetic field lines here, they're all scrambled up. And this is even reaching here to the other model. Check it out. Yeah, but I'm glad I found it because somehow I tried to find this. I couldn't. But here it's like somehow really fast. You don't get any idea of what's going on. But I think that's a very important thing because as you can see, it's a spiral. They're spiraling outwards and we are soon aligned with Mercury and Venus, and we have the high-speed coronal hole facing all three planets. And is there any possibility that due to this high-speed dark plasma stream emerging from the coronal hole that some stuff from Venus might reach Earth, especially sulfur that might penetrate Earth's magnetosphere, ionosphere and stuff like that because it's made of sulfur? Where is this zooming tool? Magnifier. The thing is, going back here, geospace magnetosphere movies. We have velocity, we have density, we have pressure. But that's it. If something is dense, we need to assume that it is made out of something. Because not only do we find sulfur on Venus, but there's also sulfur in the solar wind. Solar chemical abundances are determined by comparing solar photospheric spectra with synthetic ones obtained for different sets of abundances and physical conditions. Although such inferred results are reliable, they are model dependent. Therefore, one compares them with the values for the local interstellar medium. The argument is that they must be similar, but even for Listen, abundance determinations model play a fundamental role, i.e. temperature fluctuations, clumpiness, photon leaks. There are still two possible comparisons, one with the meteoritic values and the second with solar wind abundances. In this work, we derive a first estimation of the solar wind element ratios of sulfur relative to calcium, magnesium, two neighboring low FIEP elements using 10 years of Celsius MTUF data. We compare the sulfur abundance with the abundance determined from spectroscopic observations and from solar energetic particles. Particles! Yeah, stuff, matter, material. As we have in CMEs, as I have been talking many times. A coronal mass ejection. Yeah, mass. It's made out of something, material. Sulfur is a moderately volatile element, hence meteoritic sulfur may be depleted relative to non-volatile elements if compared to its original solar system value. And as I have been showing here, sulfur has a very big influence if we talk about heat and energy, penetrating stuff, so to say. If this here would be Earth's magnetosphere or Earth's surface, and there is a lot of sulfur coming, yeah, there's a big difference. So if there is sulfur coming from the Sun and from Venus at the same time, we might assume that there is a lot of sulfur, which could result in a deeper penetration into Earth's electrical circuitry. In other words, earthquakes, volcanic eruptions, bad weather, and stuff like this. Yes, that's why I think it's important to keep our eyes open at the moment, because there's stuff going on here. And stuff aligned here, actual time. Yeah. Like if there would be a CME at the moment, this would impact, let's say, us, Mercury, Venus, and Earth, rather immediately, because CMEs, depending on its velocity, they are going rather straight. But the coronal hole stream follows the interplanetary magnetic field lines. So there will be still some time until we have this kind of curved feature here, until the coronal hole stream reaches. And it also depends on this. Is it really, how straight are there? Are those planets aligned? If Venus seems to be a little bit on top of Earth, which might be a good thing. There might be a little bit less material, if so, coming to Earth from Venus. It will sweep by a little bit above. Maybe this helps. But anyway, I found it interesting. This is what triggered me to make this video, because somehow I found it odd that there are no planets marked here anymore. Maybe I'm watching the wrong model, maybe. But at least I found one model which is rather whirly, like spinning like hell. You don't see anything. But anyway, heads up, there might be something coming in the next few days or a week or a little bit more. Sometimes it takes a few weeks until the energy that goes into Earth comes up from the bubbles of the Earth back to the surface, and we see earthquakes and stuff like that. But that's it for now. Maybe